we will start our next presentations. Rockville Estate team, be ready.
Alshrif, you ready?
Yeah, Rockville Estate team, please, you please unmute your mic and start the presentation.
Hey, thank you. Good evening, everyone. My name is Jesus Badal, and I am the manager of the second team of this senior project presentation. We call ourselves UDC Civil Consultants LLC, and I will be introducing you to my team. Next slide. So this is the team: Keven, Kerry, Abdullah, Alsharif, Alhussm, Ernesto, and Muath. And not seen in this picture is Judith. Next slide. So our project outline is to understand civil engineering systems. It took 4 parts, which we over time started last semester, the beginning of the semester. So we started with research of civil engineering projects. Then we moved on to a small site development. And we did a culvert design using HEC-RAS. And finally, for our senior project would be the large site development. Next slide. So research on civil engineering projects. Next slide. For this, we had to research real-world problems and see how they related to our relevant coursework, what types of problems there are in the actual workforce, and how these civil engineering companies solve these problems. So to do this, we had to understand the different disciplines in civil engineering, those being environmental, transportation, water resource, surveying, construction, structural, and geotech. Next slide. So for our research, we went into the different magazines, civil engineering magazines that are available from the ASC to find different topics to research and see how things are handled in the real world. Next slide. 3 of those articles that we researched were 1, the durable design, the construction of the Mark Banside Bridge. 2, the renewable energy design, which is the design of the wind turbines. And 3, the Reno Trench project, which is the construction of the Reno Trench transportation rail corridor. Next slide. Next, we had to develop a small site. Next slide, please. So the objectives of the small site design was to gain permits to demolish a existing house. So the client gave us a house that's existing on a property, 1,500 square feet. It's an older house, and it had to be raised in order to construct a new house on this plot of land. In order to do this, we had to design for pre and post development. And to do that, we had to come up with 3 alternatives to manage the excess water that would be developed from the new development. And do this using the regulatory compliances. Next slide. So one of those things that we had to do was to be able to complete a raise permit and to be able to develop it for the client. Next slide. And come up with 3 alternatives, which one was the rain barrel alternative. Next, being 2, the infiltration trench. And 3rd, the rain garden. Next. Then for our next project, we'll be able to develop a bridge design using HEC-RAS modeling. So for this, I'll turn it over to my co-engineer, Keven.
Good afternoon, everybody. My name is Kevin Haley, and today I'll be going over our medium site project, which was the design of a culvert and bridge. Next slide. So, Hydrologic Engineering Center River Analysis System, HEC-RAS, is a computer software developed by the Army Corps Engineers. This software allows the user to perform one-dimensional steady flow, 1- and 2-dimensional unsteady flow calculations, sediment transport computations, and water temperature and water quality modeling. Next slide. So our primary objective of this project was to design new systems to replace the old ones. In the DMV area, most of the culverts and bridges were built 50 to 100 years ago, and they are deteriorating. And here are some of the data that we, we, um, we gained from the HEC-RAS modeling. Next slide. So the recommended design for the culvert that we developed was a box culvert, and this culvert here was able to produce a difference of head from the upstream and downstream river. Next slide. So in conclusion, we modeled the Kalima Road culvert where the difference of the upstream and downstream elevations were minimized to protect the infrastructure. We developed 3 alternative designs and selected the best opening so the difference in head is minimalized. Next slide. And here I hand it back over to Jesus so he can go over the large site development.
Okay, thank you, Kevin. All right, so for our Rock Creek Estates development, this is our large site development, and we wanted to show you what we've developed. Next slide. So our problem statement was designed this way. Behera, Zeytinci, and Higgs Incorporated have hired UDC Civil Consultants LLC to develop a subdivision located in Montgomery County, Maryland. 27-acre land, this subdivision will consist of single-family homes, multifamily homes, and office buildings, and shopping center. UDC Civil Consultants LLC will design the office building for 150 people, including parking lots. Next slide. So this is a picture of what we were given in the beginning, our pre-development piece of land. It's just a plot of land with a few small houses on it and trees and a lot of open spaces. And this is what the post-development is supposed to look like when we're next slide. So the client's needs, they wanted us to design a residential district with single family and multi-family homes, to design a commercial district with an office building and a shopping center, to maximize occupancy, and design to include water supply, stormwater supply, stormwater design, sanitary design, and transportation design, and to maintain pre-development conditions in the post-development scenario. Next slide. Planning and scheduling. Next slide. So in order to make our workflow run properly, we developed this sequence where we had planning and scheduling at first. We have the collection of the regulations and codes, design layout of the property, the office building design, storm management, storm sewer design, water supply design, sanitary design, transportation line design, and our delivery day. Next slide. So in order to keep everything on schedule, we developed a Gantt chart that went from the beginning of the project to today. Next slide. Layout designs. So for our layout designs, I will hand over, finish up our layout designs. Next slide, please. So we were given a plot of land and we had to develop it with certain constraints. The constraints of the property were there was a main road that ran out along the north side. There was a local road that ran along the east side, and there is a wetland that sits to the south of the property. There is also other developments around the property. Those are our constraints. So in order to use these constraints to develop, we had to come up with three different layouts for the property. This is our alternative one, which was developed by Muath, Aloudah, and Jalal. Next slide. This is our layout number 2, which was developed by Kerry and Ernesto. And this is our layout 3, which was developed by myself, Keven, and Judith. After reviewing all 3 designs, we came up with what was best about all 3, and we condensed them into one design, which is our final layout. Next. So for the development of our Rock Creek Park office, I will hand it over to my co-engineer, Keven.
So I'm gonna brief the Rock Creek Estates Office Park. Next slide. So the scope and design objectives of the office building. The scope was to design an office building with underground parking. The building to be designed in accordance with ASCE 7-10. And one of the main things was to ensure the safety of the building to avoid any future failure. Design objectives was to comfortably accommodate 150 people, optimize stormwater runoff with a garden roof, and of course be accessible to all patrons. Next slide. So the design procedures for the beams and girders. Steel beams carry the uniform load of the floor, and girders carry point loads from the beams to the columns. To select the steel beams, we use the steel design manual and steel design manual table 1-1, and of course following these steps to select the appropriate beam. Next slide. For the columns, steel columns carry point loads from each level of the building into the footing located underneath the foundation, which is then transferred to the soil. Columns were selected from the table 4-1 of the steel design manual, and we use these steps to select the appropriate column. Next slide. So this is the plan view of the office building, which is a 190 foot by 20 foot building, approximately 10,800 square feet per floor. Next slide. So the selected beams and girders. So W-shaped beams were used, and a W-shaped beam is a wide flange I-beam, where the W is the beam descriptor, 24 is the width of the flange in inches, and 76 is the weight per foot in pounds. So here you have the interior beams for the lobby with a W24 by 76, interior beams for second floor of the roof, W24 by 84, and that went on for the exterior beams and the exterior beams and interior girders. Next slide. Here, this is the elevation view of the building with 10-foot floors. And if you see, you can tell at the bottom with the blue lines, those are the underground parking. Next slide. So these were the interior column loads and the columns that we used. Next slide. And I'm gonna hand this over off to Ernesto.
Hello, I will be representing a stormwater management design. On the next slide, we have why do we need water storm management? It's to prevent excessive erosion caused by flooding. If we can, if we don't manage stormwater, it can cause excessive erosion and flooding, and this may prevent these streams from fulfilling its normal function and moving water and sediments. And in these two pictures, we can see two examples of what it can go wrong. On the next slide, we have the stormwater management plan. Reduce flow damage, minimize the increase in stormwater runoff, protect public safety, and maintain integrity in stormwater. Next, we have storm management analysis. And these are the methods that we use to calculate runoff volume in order for us to get our permits. We use the NRCS method and the rational method. The NRCS method, we use it to depth and value, and rational method to pick and discharge. On the next slide, for excess runoff, we know we have to control it. In order to do so, we had to calculate the excess runoff using the NRCS method, in which we did in pre-development and post-development conditions. Next, alternative design is green infrastructure. Green infrastructure solution can be in many different scales. It can go from houses, businesses, and small landscapes. And the second alternative design, we have a bioretention pond. And next, we recommend the recommendation we made is the stormwater pond. And we decided to go for this recommendation because we can use it on a large scale, such as the one we have designing or design. We can use it in office buildings, strip malls, and school. And this is the most common use in commercials and residential developments in order to collect and store stormwater runoff. The design of the stormwater pond will help with the restoration of natural habitats. And next, we saw for the design of storm sewer pipes, in which I will pass it to my colleague Kerry.
Thank you. After identifying the stormwater pond, we now design our storm sewer system as we collect all of the runoff from the site from upstream to downstream. We found our time of concentration to get our rainfall intensity using the IDF curve. This is used for the rational method. Okay, these are our calculations. This is the rational method calculations. We have our area, we have our coefficients. We also have our rainfall intensity. Now for this slide, we have our pipe sizes and the pipe sizes we recommended for each manhole to manhole, as you can see. Then we go into our costing for each pipe that we're using. So it's pretty much the material cost for each pipe, for each connection. Then we get a cost summary for all of our materials, not including fittings and our labor. So the total cost will be approximately $137,000. Now I'll be passing it off to Muath and Jalal as they'll discuss water supply system design.
Good afternoon, ladies and gentlemen. My name is Alhussm Jalal, and today me and my colleague Muath Bakudam will introduce the water supply system design chapter. Next. Water distribution. So the purpose of water distribution is to deliver water to consumers such as commercial, residential, or firefighting sector with appropriate quality, quantity, and pressure. Next. For the design objective, our design objective is to supply water to all the subdivision that we have, and make sure that the pressure head is enough to meet the demand and meet the current and future demand population. Next. For site layout, I'll turn it over to Muath Bakudam.
Hi everyone, my name is Muath Bakudam. As we can see in our layout design, the main pipe in the north and east side will feed our city with clear water. Next slide, please. In next slide, it's our division of the site, which is single family and multi-family and offices building, strip mall, elementary school, and restaurant. Next, please. Next slide, it's about design procedure. First, we have to design our loops, then we have to calculate it, each loop individually. And third step, we have to calculate our flow in each loop. Last step, hydraulical analysis by HEC-RAS method. Next, please. Our pipe layout. We design our system to 4 loops. Each loop serves different uses. For example, loop 1 served residential, and loop 2 served residential too, and loop 3 served residential and commercial, and loop 4 served residential and commercial. Next, please. Pipe layout network. So you can have an idea what I'm talking about, and the pipes it's serving each unit in our design. Next. The average demand flow rate can be estimated by using the following current water produced factors. The water used, we divide it into 3 sections. How many units do we have in each sections? Also, how many people lives there, and the average use of each section. Next, please. And that's how we get our fire demand, and the max daily, and the max hourly. In next slide, I will hand it over to my colleague, Hossain.
So for Hardy-Cross method, we use the Hardy-Cross method to determine the flow in pipe network And we got the head loss in each lobe using Hazen-Williams method. Next. And as you guys can see, the Hardy-Cross method, here's our table. We got the max flow, the K values, head loss, and the pressure head. That's what we gain from Hardy-Cross. Next. For the size and types of pipes used, standard pipes for our water supply design is 6, 8, and 12 inches. 6, 8 for the residential area, and 12 we believe it's for commercial. And pipes are used in our design is ductile iron pipe and cast iron pipe. Next. And finally, for our cost summary, we estimated our cost, total overall cost around $190,000, include the installation cost and everything. Next. And for sanitary sewer system, I'll turn it to Mr. Jesus Badal.
Thank you, Jalal. All right, so for the sanitary sewer design, I will be speaking. So the sanitary sewer system was designed to remove all the water that's being brought in and waste that's been developed in the community during the any water that's being brought in has to be taken out. So next slide, please. The design objectives of our sanitary sewer system is to convey the wastewater produced by the 27-acre site to the RCP trunk located to the northeast of the site. We have to satisfy the sewage needs in accordance with the regulations and codes of the county, and also reduce the chance of seepage and pollution by properly sizing the sewer system. Next slide, please. This is a snapshot of our pipe layout. As you can see, all the manholes, the elevations, the slopes are shown on this picture. Next slide, please. So our design rationale, in total, we had a 4,442 feet of sewer pipe to take care of the site. 2,805 feet of it is 8-inch, 960 feet would be 10-inch, and 731 feet would be 12-inch. And they are all SDR 35, which is in code according to the Montgomery County Code. There will be 60 manholes for each section. The network is designed as a gravity flow system and does not use pumps or powered equipment, and it connects to the RCP network. Next slide, please. So gravity sewers are designed to be low impact design. They're not supposed to have any odors. It's supposed to be a durable design. It's supposed to reduce the presence of pests and vermin who would otherwise feed and live in any waste that's produced. Reduce the spread of dangerous pathogens and diseases found in human waste, and flow naturally without the use of pump or machinery. Next slide, please. So the criteria for this design is the sewer must be designed in accordance with the academic engineering design resources that we are given, which is what we are taught here at UDC, as well as the state and county regulations. The design must consider all the local environment as the design parameters. Must be designed using Manning's N number 0.013, which is according to Montgomery County Code, I mean. Design must maintain a minimum scour velocity of 2.5 feet per second at half full condition. Next slide, please. So the design criteria continued with we're stating that the manholes have to fit all of these criteria in order to meet the codes presented by Montgomery County. They have to have at least an 8-inch diameter. The manhole shaft must be precast concrete. The sizes must be between 48 and 60 inches in diameter. Must be at a depth between 4 and 20 feet. And the manhole 60 diameters or deeper, 60 inches or deeper must have fall prevention installed. Next slide, please. So this is a layout of the sanitary sewer design. The manholes are located in the nodes as predetermined from the pipe layout I showed earlier. Next slide, please. And this is it with just the houses and how they connect to the trunks. Next slide, please. These are the equations that we use to calculate the velocity, the flow, and the slope of the pipe system through the site. Next slide, please. So for our Q design, we assume that the water that's being discharged from the site is 100% of what's being brought in. So using the population, we developed the Q domestic, which we develop our peak flow, and then turn into our ultimate flow, which is our Q design, in order to develop our pipe sizes. And also considering the street elevations, we develop our slope. Next slide. For our hydraulic design, taking those parameters that we did in the previous slide, we started developing our diameter using tables from the design manual, also tables from the textbooks that we use to come up with the recommended diameter of the pipe. Being that the diameter is below 8 inches, we had to go with the regulation minimum, which is 8-inch pipes for those that fall below 8. And using that, we checked for our velocity and our slope using the calculations. Where we have the slope was too small, we used the recommended slope and then check our velocity, which is above 2.5 feet per second, which makes us within. Next slide, please. So we did a cost estimation based on the material that was needed for this project. In total, our cost was $125,053.50 for all material. We did not consider labor or excavation costs in this price. Next slide, please. Next, we will talk about transportation design. I will hand it over to my colleague, Mr. Aloudah.
Hi everyone, my name is Abdullah Aloudah. Today I'm going to talk about transportation design for our project. Next slide. The scope and objective. Okay, so objective: reduce changes of any road accident by adopting necessary measure. The design fulfills the accessibility and mobility needs of residents. Easy and safe access to commercial development inside the community. The design encompasses the future needs of growth in traffic and overall population. Scope A: identify different zones of land use, forecasting the traffic demand of all the zones within the development. C: design the transportation system to support the new development. D: estimate required parking spaces for the development. Next slide, please. Here, as you can see, is our road network. Next, please. And here, as you can see, parking calculation, which include all the zones from A to N. Next, please. And parking demand analysis. Parking generations supply rates of each zone are taken from ITE parking generation manual 4th edition. Required parking spaces for each zone are demanded by multiplying average parking supply factor for the population zone with built up area and or dwelling units. Total area required is estimated by length divided by width divided by parking spaces needed. Next, please. Here, as you can see, is the typical cross section. Next. Typical cross section is length with 12 feet inside shoulder, 1 feet, sidewalk, 3 feet, roading, 1 feet, cross slope, 2%, side slope, 4%. And next slide. And here's I will pass it to Abdullah Sharif. Thank you.
Hello everyone, my name is Abdullah Alsharif. My part was working on transportation most of the time, and I'm going to talk about the 4 steps models. So I'm going to start about 4 step models, which is trip generation, trip distribution, mood choice, and route assignment. So let's start with the zonal distribution and trip generation. So development is divided in 14 zones, as you can see here, from zone A to zone N, and trip generation rates are individual for each zone based on IT trip generation manual edition, and trips are estimated by built up area multiplied trip generation rate multiplied peak hour entering. So as you can see here, total trip AM peak hour entering trips 169, AM peak hour exiting 167. Next slide, please. And built trip generation. Trip generation is built area number development in case of resident are estimated. Next slide, please. Trip distribution. Trip distribution is to estimated number of vehicles that entering from zone to another zone. Travel time matrix is development based estimated time for each zone to each zone. Correction factors based on travel time matrix are used to format for OD matrix. Next slide, please. So task 3, route assignment. Route assignment, this system is used to determine the route the route drivers select to reach their destination. As you can see here, number of lanes are estimated based on loss and profit based on row available for each link. Next slide, please. Task for traffic control. As you can see here, signals intersection equal 1, asphalt facing, cycle time estimated based on WebS models, delay estimated based on HCM methodology, loss estimated based on HCM methodology, always stop control intersection equal 11. Next slide, please. And here I pass to Asus.
All right, thank you, everyone. So, in summary, we were able to develop this project in order to meet our clients' needs. We were able to develop 47 single-family houses, 100 multifamily houses, 1 elementary school, 1 office building, and 1 shopping center. We are able to service 635 people at this site, with office building that has 10,800 square feet per floor for 6 floors, which is 64,800 square feet in total. We have a commercial space of 28,125 square feet, and it's a completely green neighborhood, walkable neighborhood. So we'd like to acknowledge our department, University of the District of Columbia Engineering of Applied Sciences. We'd like to acknowledge the professors that helped us through this design phase, Dr. Behera, Dr. Wang, Dr. Z, and Dr. Higgs. And we would like to thank you all for taking part in our presentation. Thank you. Any questions?
Any questions, please?
No, I don't have any question. Again, excellent work. You guys are really on the ball down there. Appreciate everything. Thank you.
Thank you, sir.
Pradeep,
Yes.
would you please introduce Howard? You have such a great engineer with us. So you may want to say a few things about Howard Gibbs, senior PEPCO engineers.
Well, Howard Gibbs is now,
He's an icon.
fellow of NSP, and he has been a great supporter of our department since I've been here the last 20 years. I know. So
Yeah, yeah, and students also will know now.
yeah. So
Don't forget, I graduated from UDC a few years ago too.
That's what I was waiting for.
yeah,
You may want to call few decades ago, maybe.
sure. Actually, on behalf of Department of Civil Engineering, I really, thank you for our advisory boards members for their time to be present to showcase and our students. They have been working hard. They have presented their topics and they will submit their final report by Monday. They're working and finishing all the line. If you have any general comments or questions, please, both the teams are there. They can answer. My computer is going to be, it's present, but you go ahead, please. Yes.
I just wanted to congratulate both the teams. They did a very good job on presentation and all the detailed calculation. And I can recall my younger days when I was involved in some of those comps. But congratulations to both, and they did a very good presentation. And I wish we could see all the presenters. Some of their cameras were muted, but otherwise the slideshow was great. Thank you and congratulations both. Thank you.
Thank you, Professor. Thank you.
Thank you. Thank you.
Thank you. Thank you, everybody.
Thank you so much, sir.
So with this, the presentation is over.